My name is jiahaoshi. My ZID is 5569517, and this is my student card. My speech today is about experiment assessment. Kepler's first law states that every planet moves in an elliptical orbit around the Sun, and the Sun located at one of the two focuses of the ellipse. It breaks the long-held belief that planetary orbits were perfect circles. Kepler's second law describes the speed at which a planet moves along its elliptical orbit. According to the law, a line segment joining a planet and the Sun sweeps out equal areas during the equal intervals of time. Kepler's third law established a relationship between orbital period and the size of its orbit. To be specific, the square of the orbital period is proportional to the curve of the semi-major axis of its elliptical orbit. For question 9, the planet moves as the moon orbits. The mass center located at the line between star and planet. Considering the mass of star is far more than the mass of planet, mass center would be closer to star. The planet move center still located at the line between planet and the moon. However, since the ratio of mass between the planet and the moon is less than the star-planet ratio, so it may not be such close to the planet. For question 11, the grid is half astronomical unit since the distance between planet and the moon is defined at 1 astronomical unit. Here is result for question 14. The result follow Kepler's third law. Kepler's third law indicates that the square of the orbital period of the planet are proportional to the cube of the semi-major of their orbits. The ratio is almost the same, matching the Kepler's third law. From the experiment, it gives me a direct feeling of how Kepler's law, the first law, relieves the shape of the orbit. Second law proves the change of speed during the orbiting. Third law indicates the relation between orbital period and its shorter half-axis. Also, I learned influence of gravity on the orbiting. This knowledge deepened my understanding and about planet orbiting motion and how to apply theoretical knowledge into real case. Thank you for your listening.